The Lena River, a colossal artery of Siberia, carves a path across a territory rivaling Western Europe in size, much of it still a verdant, uncharted wilderness. Along its banks, whispers of civilizations long gone, impossibly present in this frigid climate, stir the imagination. Within its depths dwell creatures that defy easy categorization, known to science yet profoundly mysterious. We embark now on a journey to unravel one of the many enigmas held within this magnificent waterway. For 40 kilometers, the Lena's shores are guarded by colossal vertical columns of rock, soaring up to 100 meters. Early Russian explorers, awestruck by their geometric precision, mistook them for ancient fortress walls. The indigenous Yakuts revered this place, the Lena Pillars, deeming it sacred and approaching only when absolutely necessary. These geological sentinels are composed of Cambrian limestone, dating back approximately 500 million years. While the general mechanism of their formation, selective erosion along vertical fissures, is understood, the true puzzle lies in the astonishing geometry of the fracture system that birthed them. The cracks form an almost perfect rectangular grid, with intervals of irregularity that strains credulity for any purely natural process. Geologists who have meticulously studied the pillars note that the angle of most vertical fissures deviates from true perpendicularity by no more than 2 or 3 degrees, a remarkable consistency across the entire 40-kilometer stretch. For a random geological event, such statistical regularity is highly improbable. The precise forces that engineered such a uniform fissure network over such a vast distance remain a subject of ongoing debate, an unanswered question etched in stone. At the base of these ancient pillars, a treasure trove of exceptionally preserved Cambrian fauna is regularly unearthed. Trilobites, archaeocyathids, brachiopods. This is one of the rare places on Earth where one can hold in their hands an organism that lived 500 million years ago. Yet, within this paleontological bounty, anomalies persist. Certain species found in one stratum are inexplicably absent from adjacent layers, defying the expected ecological progression of the Cambrian period. The Lena itself, one of the world's great rivers, lacks a comprehensive bathymetric map. Its average depth, across much of its course, is a modest 10 to 15 meters. However, in certain sections, sonar readings reveal depths far exceeding what its placid profile would suggest. In the middle reaches, between the confluences of the Aldan and Viliui rivers, colossal basins plunge to depths of 60 to 70 meters, anomalous chasms for a river of this character in a predominantly flat landscape. Their origins are debated. Some geologists attribute them to tectonic fault lines, others to ancient karst collapses, subsequently buried by riverine deposits. Local fishermen, who have plied these waters for generations, speak of peculiar behavior in the depths. Their instruments occasionally register signals that correspond neither to the riverbed's topography nor to any known biological activity, adding another layer to the Lena's profound and enduring mystique. The river, a conduit of time and mystery, continues to guard its secrets, a testament to the Earth's ancient, unfathomable power. In the vast, untamed expanses of Siberia, the Lena River system, one of the world's great arteries of fresh water, flows with an ancient, enigmatic power. Yet, despite its significance, it remains one of the least studied of the planet's major river systems. This is not solely due to technical complexities, but rather the sheer inaccessibility of its vast basin and a perceived lack of economic priority. The Viliui, the Lena's largest left tributary, carves its path through a land that the indigenous Evenki people named Yelu-Cherkichek, the Cursed Valley. This name, steeped in oral tradition long before the arrival of Russian explorers, hints at a history far older and perhaps stranger than any written record. Geologically, the Viliui Basin is a landscape of profound anomalies, a place where the Earth's inner forces have most significant diamond deposits are found. These are not mere veins of precious stone, but vast kimberlite pipes, colossal conduits formed by explosive volcanic eruptions from depths as profound as 150 to 200 kilometers. The Mir, Udachny, and dozens of other kimberlite pipes are testaments to geological processes that unfolded in successive waves over hundreds of millions of years, a violent birth of diamonds from the planet's fiery heart. But the Vilyu's strangeness extends beyond its mineral wealth. The region is characterized by persistent magnetic anomalies. In numerous locations, compass needles deviate by several degrees, a disorienting phenomenon with no apparent geological cause. Thermal anomalies, too, manifest themselves. Inexplicable outpourings of geothermal heat, disproportionate to any known subterranean structures, have been recorded in several isolated spots. Whispers of these anomalies echo through the accounts of 19th-century Yakut hunters. They spoke of metallic, dome-shaped objects, partially buried within the earth, emitting a warmth that offered refuge from the unforgiving Siberian frost. Soviet expeditions in the 1930s and 1950s, driven by these tantalizing legends, searched for these enigmatic structures, but their efforts yielded no definitive documentation. The prevailing geological hypothesis posits fragments of ancient kimberlite formations with unusual mineral compositions. Yet these purported objects remain undiscovered, their existence unconfirmed. Along the banks of the Lena and its tributaries, the permafrost, that eternal keeper of the north, regularly yields its ancient treasures. Each summer, as the frozen ground thaws and slumps, it releases what has been entombed for millennia. The remains of Ice Age megafauna emerge from the collapsing banks, a poignant tableau of a lost world. The preservation of these finds consistently astounds researchers. Tissues, fur, even the contents of ancient stomachs are found intact, preserved in conditions that, according to standard biochemical models, should have led to complete decomposition thousands of years ago. While the general mechanisms of permafrost preservation are understood, the intricate biochemical processes that allow soft tissues to endure for 40,000 years, and sometimes longer, remain a subject of intense scientific scrutiny. However, the most profound enigma presented by the Lena's thawing shores is not the remarkable preservation of individual specimens, but their peculiar distribution. Mammoths perished across a vast geographical area over countless millennia. Yet, certain stretches of the riverbanks exhibit a concentration of these ancient remains that far exceeds any statistically predictable pattern. It is a geographical puzzle, a silent testament to events or conditions that defy simple explanation, leaving us to ponder the secrets still held within the frozen embrace of the Siberian earth. These are localized sites, gathering points for animals in the final periods before extinction. What drew them to these specific locations? Mineral springs, unique topographical features, or something else entirely, remains unknown. In 2013, on the Liakovsky Islands, a mammoth was discovered bearing a cavity filled with a dark, liquid substance. This marked the first instance of a liquid biological material being found in a specimen of such antiquity. Remarkably, at a temperature of -10 degrees Celsius, this fluid refused to freeze, suggesting the presence of sophisticated biochemical antifreeze mechanisms. The precise nature of this phenomenon is still under investigation. The Lena River, a colossal artery stretching for 4,400 kilometers, is fed by hundreds of tributaries. The river's hydrological balance, the intricate relationship between the volume of water flowing from its tributaries and the overall water level in its main channel, has been the subject of meticulous multi-year measurements. Within this complex equation, hydrologists have observed a persistent anomaly, a discrepancy they can record but cannot fully explain. During the Lena's low water season, known as Mezhyn, when summer water levels are at their minimum, the flow from several tributaries dramatically diminishes, often dropping to near zero. While this is a natural occurrence for smaller rivers during arid periods, the puzzling aspect is the rapid resurgence of these tributaries in the autumn. Their flow returns far more quickly than can be accounted for by the precipitation recorded in their respective basins. Water reappears, seemingly from nowhere, arriving before surface runoff could possibly deliver it. Hydrologists are exploring a compelling hypothesis: subterranean feeding through karst and talc systems within the permafrost. Beneath the seemingly impenetrable layer of permafrost lie talcs, unfrozen aquifers capable of storing and redistributing water independently of surface conditions. However, the precise configuration and interconnectedness of these hidden water networks within the Lena Basin remain unmapped. This implies that a significant portion of the water coursing through the Lena originates from these unseen, unmeasured underground systems. The true volume of this subterranean contribution to the water budget of one of the world's most significant rivers is, as yet, an unknown quantity. Along the exposed rock faces that line the banks of the Lena and its tributaries, thousands of petroglyphs have been documented. The most significant clusters are found near Shishkino in the Irkutsk region and in several remote locales within Yakutia. The Shishkino rock carvings, or pisanitsi, contain depictions that span from the Neolithic era right up to historical times, representing thousands of years of human presence in a single location. This continuity strongly suggests that these sites were considered sacred, drawing generations of diverse cultures over millennia. Different peoples in different epochs were drawn to the same ancient rock faces, leaving their indelible marks. Yet, the chronological enigma of the Lena's petroglyphs lies not in their prolonged use, but in the content of their most ancient layers. Certain depictions, tentatively dated between 12,000 and 15,000 years ago, feature figures that do not align with the known fauna of the region during that epoch. These are animals with anomalous characteristics, their forms defying definitive identification by researchers. Alongside these enigmatic creatures are geometric figures, patterns that appear unparalleled in other petroglyphic complexes across Siberia. They speak of a past more complex and perhaps more mysterious than our current understanding allows. The very earliest techniques for etching the deepest layers of imagery demanded tools crafted from a material as hard as granite. What specific substance was employed by the peoples of the Lena region 12,000 years ago? The answer remains elusive. The Lena Delta, one of the world's most immense river deltas, sprawls across approximately 32,000 square kilometers, a mosaic of over 1,500 islands. It is a landscape in constant flux, where islands emerge, accrete, erode, and vanish with a speed that outpaces the creation of maps. But beneath this dynamic surface, a more profound transformation is underway. The permafrost within the delta is thawing from below, a consequence of its contact with unfrozen seawater. This process triggers ground subsidence, the formation of thermokarst lakes, and a gradual reshaping of the terrain. Projections suggest that within the coming decades, the delta's configuration will alter so dramatically that contemporary maps will become obsolete. In the year 2020, satellite observations detected several points within the delta where methane was escaping from shallow coastal waters. The intensity of these emissions far surpassed the baseline levels for the region. In summer, at these specific locations, the water appears to boil, alive with escaping gas bubbles. The Lena Delta serves as a critical nesting ground and staging post for tens of millions of migratory birds. Ornithologists working in the area are documenting shifts in their migratory routes. Birds have begun to avoid certain sections of the delta that they previously utilized. The precise reasons for these changes in those specific locations remain undetermined, with insufficient data to draw firm conclusions. The omul, a species of whitefish, stands as one of the primary biological icons of both Lake Baikal and the Lena River. The Lena population of omul is genetically distinct from its Baikal counterpart and from omul found in other Siberian rivers. This divergence persists despite the rivers being interconnected through a system of tributaries, theoretically allowing for the exchange of individuals. This suggests the Lena omul has evolved in isolation, though the mechanism of this isolation is not immediately apparent. Fish are capable of crossing watersheds via temporary connections formed during river floods. Nevertheless, The populations have diverged genetically to such an extent that some researchers are considering the designation of the Lena omul as a separate subspecies. An even more intriguing enigma surrounds the migratory behavior of the Lena omul. These fish feed in the Delta and the Laptev Sea, but undertake a spawning migration upstream, traveling distances of 1,500 to 1,700 kilometers. This represents one of the longest spawning migrations observed among freshwater fish globally. How these fish navigate such vast distances and locate their specific spawning grounds remains an unanswered question. Is it magnetic sensitivity, a chemical memory of their natal river waters, or something else entirely? The mechanism of their navigation is still a subject of open inquiry. In recent years, fishermen along the Lena have noted changes in the timing of the spawning runs. The omul are beginning their upstream journeys several weeks earlier than usual. This behavioral shift has been documented, but its underlying cause has yet to be definitively established. The delicate balance of this unique ecosystem, shaped by millennia of geological and biological processes, is now responding to subtle yet significant environmental shifts. The future of the Lena, its islands, its wildlife, and its ancient mysteries hangs in a delicate, ever-changing balance. Where the Lena River meets the Laptev Sea, two vastly different aquatic systems converge. Freshwater, laden with immense quantities of suspended particles, encounters the saline embrace of Arctic waters. The boundary between them is no clear-cut line. Instead, it is a zone stretching for tens of kilometers, a dynamic frontier where physical and chemical parameters shift in a nonlinear fashion. Within this transitional zone, anomalous acoustic phenomena have been recorded. Hydrophones, deployed by joint Russian and German research expeditions, capture low-frequency sounds that defy explanation. They do not align with known biological activity, nor with predictable hydrophysical processes at this interface. The Laptev Sea is a significant source of Arctic sea ice. A substantial portion of the ice in the Eurasian basin forms here, influenced by the outflow of fresh water from the Lena. This means the river exerts a profound influence on the entire Arctic ice regime. While the broad strokes of this mechanism are understood, the precise contribution of the Lena to the Arctic ice balance remains a subject of ongoing refinement. On the seabed of the Laptev Sea, within the Lena's zone of influence, accumulations of organic material have been detected. This material, carried by the river over millennia, settles and, under the immense pressure of the water and the frigid conditions, forms gas hydrates, solid compounds of water and methane. These hydrates are unstable in warming waters. The scale of these hydrate deposits in the Lena Delta region remains unquantified. For millennia, the Evenki, the indigenous people of the Lena Basin, have passed down oral traditions about the river. Before the advent of written language, these legends were the sole repository of knowledge about their homeland. Researchers studying Evenki folklore during expeditions in the 19th and 20th centuries recorded something unexpected. Descriptions of specific locations, fords, rapids, unique points along the river, correspond with the actual geography with a precision that strains credulity for mere narrative. The Evenki names for these places often encode information about their physical characteristics. Depth, current, the nature of the riverbed, all were encoded in linguistic forms that allowed for the transmission of navigational knowledge without the need for maps. The Finnish linguist Kastren, working with Evenki informants in the 1840s, documented descriptions of several sites on the Lena, detailing characteristics he could not verify in the field. Subsequent hydrological expeditions confirmed a number of these descriptions with an accuracy that defies coincidence. Some Evenki traditions speak of changes in the river's course, places where the Lena once flowed differently. Geomorphological analysis has corroborated that in several of these described locations, former river channels did indeed exist. These ancient narratives, etched into the very language of a people, hold a remarkable echo of the land's deep history, a testament to a profound and enduring connection between humanity and the powerful forces of nature. The Lena River, a colossal artery of Siberia, carries within its currents the echoes of millennia. Its ancient, abandoned channels whisper tales of a landscape transformed over thousands of years, a history preserved in the oral traditions of the Evenk people. In 2019, a joint Russian-German hydrological expedition embarked on a mission to understand the river's acoustic environment. Along the middle reaches of the Lena, sensitive hydrophones were deployed, tasked with a seemingly routine objective: to capture the baseline soundscape for future ecological comparison. On the third day of their work, the instruments registered something entirely unexpected. A recurring low-frequency pulse emanating at precise intervals of approximately 4 minutes. The sound itself lay in the infrasound range, far below the threshold of human hearing. Crucially, the signal originated not from the river's surface or its water column, but from beneath the riverbed itself. The researchers meticulously examined every conventional explanation. Seismic activity in the region was absent. Industrial noise, the nearest sources lying over 200 kilometers away, was ruled out. Biological origins were also improbable. Known freshwater species capable of generating infrasound in this specific frequency were not native to these waters. Even geological phenomena, such as gas emissions from sediment layers, produced an acoustic signature that did not match the recorded pulses. For 11 days, the hydrophones continued to document this enigmatic signal. Then, as abruptly as it began, it ceased. Throughout this period, the instruments detected no discernible changes in water chemistry, temperature, or any other environmental parameter that might hint at the source. The expedition's findings were published in 2021 in a specialized hydrological journal. In the conclusions section, a single, profound statement: requires further study. The Lena flows through one of the planet's least explored territories. Its depths remain largely unmapped. Its tributaries are fed by unseen subterranean systems. Its banks have yielded the frozen remains of animals from 40,000 years ago. Within its waters swim fish that possess an inherited memory of journeys spanning 1,500 kilometers. And somewhere, on its unseen riverbed, in 2019, something emitted a sound, with a regularity of precisely 4 minutes. And then, it fell silent. Much of this remains documented, yet little is fully